Welcome to a new lesson. In this lesson, we would learn about Pig, which is a part of Hadoop ecosystem. Whenever you are starting to know about any of the ecosystem, it is of a lot of importance that you know the origin of the ecosystem and the main idea and the reason behind its need. Pig has been developed at Yahoo. Around the same time period, Facebook worked on Hive. So you would see that the ecosystems were not initially conceptualized to work alongside each other. And so you would see that there is an overlap in capabilities and solutions might be possible in variety. Another issue you would observe is of compatibilities between the Hadoop ecosystem. So coming to Pig, it was initially developed and conceptualized at Yahoo. And the idea was to help data scientists to give ability to write MapReduce programs quickly and easily. As you would have seen, the join operations in MapReduce framework can easily take over 100 lines of complicated code. Firstly, it takes a lot of time to develop. And secondly, it is very difficult for the data scientist to put that kind of time in development and have skills to do that kind of a complex programming. This challenge gave birth to higher language framework that is Pig at Yahoo. Idea behind Pig was to provide a simpler alternative to MapReduce. So let us compare Pig and MapReduce in terms of their capabilities to understand which one should be chosen over the other and in which situations one performs better than the other. First of all, it is recommended that Pig should be used in complex join operations. As we would see later in the slides, development efforts would vastly reduce. However, one thing that should be kept in mind is that solutions written in MapReduce are highly optimized and give less turnaround time. So if you're thinking of writing a reporting job which might be executed more frequently and on a larger data set, you might consider to write it in MapReduce. Pig written scripts or programs are parsed and converted into MapReduce programs. So it should be understood that Pig solutions are not optimized solutions. But with time, the optimization is being worked upon and the gap is being closed. Having said that, Pig solutions would be slower than MapReduce solutions at least till some time in future. Pig is highly capable language and most of the operations that can be done in MapReduce can be easily be done through Pig. So it is highly capable language, but it doesn't have the capabilities to touch only a small portion of dataset. It scans the whole datasets with each operation. So capability-wise, it is almost as strong as MapReduce, but just a little less stronger. Now let us take a look at Pig in a little more details. Pig has two components. First is Pig Latin, which is the programming language, and second is the environment which is required to run Pig programs. The environment is nothing but a tar file that needs to be installed at the client node, which translates the Pig queries into MapReduce jobs. So the environment can have the following two types of setup. First, the local mode execution, and the second, MapReduce mode. In local mode of execution, Pig runs on a single JVM, whereas in MapReduce mode, it translates the Pig program to MapReduce programs and connects to Hadoop and runs it on the Hadoop cluster. At this point of time, it is to be very well understood that there are a lot of compatibility issues between all the Hadoop ecosystem elements, and hence it is advised that compatibility is to be cross-checked with the release nodes. And this applies to every ecosystem. There can be three ways in which Pig Latin can be coded. Firstly, it can be coded as a script, where a bunch of commands are coded to perform the functionality. Pig script files would end with .pig extension. Then there is grunt mode, which acts as an interactive shell for running Pig commands. Then there is an embedded mode where Pig commands can be embedded into a Java program. In that case, you would have to use Pig server class just like you use JDBC to run SQL code in Java. Next, let us look at an example on how things work in Pig. On this slide, we'll go through a set of commands as if it runs in an interactive mode, that is the grunt mode. Just remember that Pig is a data flow language. Let us again bring about the same example dataset which we had considered in the previous lesson. Let there be billing details, having project number, employee ID, number of hours billed on that project, and the billing rate. Firstly, we see a pig load command. A equal load, then comes the URI of the file that is to be loaded, followed by the schema which should be used to read. Here the columns are delimited by a comma, and based on that parsing would happen. Pig has many features to read files with different kinds of delimitations. In the second portion of the statement, we specify the schema which has the column name and the data type. Pig has its own data types and they can be used to form composite complex data types as well. So here the first column is prj_num, which acts as a char array. Then empid, hours and bill rate act as integers. This load command loads the dataset in A. It is to be observed that Pig is a data flow language, and here you see the assignment of dataset to a variable, and then the operation performed on the variable to get the desired result. Next, let us see the filter command. In filter, we can specify a condition based on which the complete dataset would be scanned, and the record that would pass the condition would be taken out for the result dataset. The resultant dataset can be seen through a dump command. For example, filter A by project num equal to prj001 results in records with prj_num as prj001. The result of any command is termed as a relation, and every record is termed as tuple, and every variable is technically termed as an alias. So a filter A is termed as an alias of the resultant relation. The dump command is used to display the dataset on the screen. So dump filter A would produce the shown relation. Then another operation that can be done on a dataset is the group operation. For example, group A equals group A by prj_num. This means that we would group the relationship in the specified alias by prj_num field. Dump group A would produce the result as shown. The first field of each tuple would be the field on which grouping operation is performed. The second element is called as a bag, which is unordered collection of tuples which have the corresponding project number. Each element in the bag is separated by a comma. Here in this case, there would be 2 tuples in each bag. Next, let us look at how easy it is to write the join operation. First statements are load commands to load the dataset into alias. Then by a simple command as shown, join operation would be performed. $0 represents the first column in the respective alias based on which the join needs to be performed. So writing complex operations is really simple in Pig. So when you think of Pig, always remember these points. Firstly, it is a data flow language. Then it was designed for data scientists who didn't have Java or a complex language background. Hence, this is a high-level language which is easy to implement. It was developed for a fast-paced development of a solution and is ideally suited for complex operations like the join operations. It is almost as capable as MapReduce but not as completely strong. Pig scans the complete dataset and is not suited if looking for small portions of data. Pig is a little slower to execute than Java written jobs, which are highly optimized. However, with every Pig release, that gap is coming closer. Pig runs a series of MapReduce programs under the hood. This finishes an introduction about Pig.